Hello, welcome. Let's have the continuation on the static mechanic series that we are doing. Episode 23 is where we are now. Here we want to look at equilibrium of what? Particles or particles that are in equilibrium. Or better still, looking at what? The coplanar forces. So we are saying that um, if the forces acting on a particle are in the same plane, if the forces that are acting are in the same plane, they are called coplanar forces. Remember, we talked about the concurrent forces that are acting from the same point. This is coplanar, in the same plane, in different directions. All right. Then forces can act in all direction on a body or a particle. So it can be in any direction, upward, downward, left, right, any direction at all. Now, if all the forces acting on the such a body cancel each other out, that is, the forces cancel each other out, the upward force and the downward force cancel, the left and right cancel, so that nothing happens at all. Forces acting causes a body to move. So if the forces are acting upward, downward, and the body still remain at rest, nothing is happening, then the system of forces are said to be in equilibrium. So if there's nothing, so this is where we have that if this is on the surface, there is the surface exerting a force on this body, upward, normal reaction. The object, which is the body, also is exerting a force on the surface, which is the weight. Then if there is a small force applied here, which will have caused this body to shift to the right, there will be a frictional force also that will like to push it backwards. So that if the frictional force equals to the applied force, if the normal reaction equals to the weight, it means that both forces, nothing is happening on this body. The body is still at rest. It is not moving nor coming down or sliding. Then we can say that that body is in equilibrium. So when the body is in equilibrium, what does it mean? So a particle is said to be in equilibrium or said to be at rest if the resultant or vector sum of all the forces acting on this body is what? Zero. When all the forces acting is zero, we call that body to be at rest, or the body is in what? Equilibrium. All right. So thus, the resultant of that force is going to be equal to what? Zero. Remember how you find resultant of all forces. If we are looking for the resultant, you add all the forces together in the vector column form. But in this case, if you add all these forces, 1, 2, 3, up to any number given to you, your result is going to be what? Zero. I think that is clear. The introduction of zero bring in a different perspective to what we have done in the previous episode. So let's look at an example. Two forces. But here also, remember what we are being indicated here. Vector sum. It means that the forces must be resolved from the magnitude direction form to a vector form or into Cartesian plane before you can add them. You cannot add them raw the way they are in the magnitude direction form. So if two forces which are in magnitude and direction, and the second force magnitude direction act on a body, find the magnitude of the third force that will keep the body at what? Rest or at equilibrium. We need the third force. It means that the force 1 plus the force 2 plus the third force should give us what? Zero. So what do we add to these two forces that will make their resultant to be what? Zero. That is the concept we are coming to employ. All right, so from here, what do? We need to, okay, let's say, let me write solution to distinguish the title. So we have solution. So that means the title is different. So here we can say that let the third force be add. So we can say that since the body is in equilibrium, we can say that the first force P plus the second force Q plus the third force R all will give us what? 0. So we resolve force P and Q into the vector form. If I pick the first force, which is P, the first thing I need to do to have my P equals to what is the magnitude? 4. What is the angle? So we have sine of the angle what? 60. 4 cos of the angle what? 60. Let's resolve that. Sine 60 times that of 4 will be giving you 3.46. Then the second one, which is also 4 cos 60, will give you 2. So this is in what? Newton. Okay, so let's see. We go for the second force, which is force Q, right? So Q will also be resolved in the magnitude of 2 sine the angle of 225, 2 cos the angle of 225, all in degree. Let's resolve that and see. We have 2 times the sine of 225. That gives us a negative 1.41 if you are using 2 decimal place. Then 2 cos 225 will also give us negative 1.41. I think the same value. So we have our Newton. So now remember, this value plus this value plus that of R is equals what? 0. So let's find that equation and move on. So from here we can just say directly, this implies that the P vector, which is 3.46 and 2, should be added onto by the Q vector, which is negative 1.41, negative 1.41, all plus R should give us what? 0. So fast forward, 3.46 minus 1.41, 2 minus 1.41, all this plus what? This equals 0. If you subtract that, that should be 2.05. So we have 2.05, then 2 minus 1.14 or 41. That one should be giving us 0.59. All this plus what? R equals 0. We need this. So we transpose this. It's going to be negative from here. This positive. When we move it here, it becomes negative in front. So negative affect that to give you negative 2.05, negative 0.59 as the next word, force. This is the force. When added onto the first two forces, will keep the body to be in equilibrium. But we are asked to find the magnitude of that force. So the magnitude simply means that we are finding the square root of the square of the x component plus the square of what? The y component. And that should be root. The first one should be 2.5 or 2.05 all square. Should be 4.2025 plus the second one should be 0.59 all square. Should be 0.3481, right? Yeah, 81. So let's put all together and see. So we put all together, we have 4.5506. Let's leave that under the root and see what that value will give us. So this will be giving you 2.13 Newton. So knowing the resultant, we can find the magnitude. We can also use the resultant to find the direction of that particular force. This is just magnitude. The first two forces are having magnitude and what? Direction. So we can also find the direction of that force using this in the Cartesian plane, find the acute angle it formed with the x-axis, then we move from north to that force. Very simple, right? All right. This is to text the concept of equilibrium of forces. In the subsequent one, we pick a series of questions to text this the more. Like, share, comment, and subscribe.